Hey guys, this is Coach Brian doing a quick reteach on 45, 45, 90 triangles. This is something from CIA number 4 that overall we just didn't do so great on, and it's going to be used again in Unit 11. So we're going to just use this opportunity to recover it. So when we're talking about a 45, 45, 90 triangle, we are referencing its angles. So obviously we have the 90 and all of the triangles angles add up to 180. And because these two sides match, their opposite angles are congruent. That's something we learned pretty early in our study of triangles, was that when two sides are congruent, like they are here, when two sides are congruent, their opposite angles are the same. And so if these angles have to be the same, and all three of them, 1, 2, 3, have to add up to 180, then they must be 45 degrees each. So 45, 45, 90. This is also what we call an isosceles right triangle. All right, so you can see both of these questions give us different information. The first one gives us the hypotenuse. So these do have a pattern, but to work them out, I'm just going to start by using the Pythagorean theorem. A squared plus b squared equals c squared. Now, here's the thing. We know that a and b are our sides, so we can just say this is a and this is b. And then c is always our hypotenuse, so that's c. We know that a and b are the same. So let's just say, to start off with, that they are x. We don't know what they are, but they're both x. So I would say x squared, because that's a, plus x squared, because that's b, equals 12 squared. And if we work that out over here, all right, these are 1. So 1x squared plus another x squared. If I take these two and put them together, I get 2x squared. 1 plus 1 is 2. And then over here, I get 144, because that's what 12 squared is. Now, I would just solve this algebraically. Divide by 2. Okay, that cancels. X squared equals 72. And then to cancel an exponent, I use a root. So if I want to get rid of an exponent of 2, I have to find the square root. So that leaves me with x. Whatever I do to one side, I have to do to the other. Well, 72 is not a perfect square. So I'm just going to move this down here. And so we would have to simplify the radical. And so I like to always try to find a perfect square. So you would be like, okay, what goes into 72? Does 9, does 16, does 25, does 36? And you would just want to try to pick the largest one. 36 goes into 72 2 times. That's a perfect square. It breaks down into 6 and 6. I can cross one out and kick one out. And, sorry, I wrote that incorrectly. X equals 6 square root of 2. So both the sides of this triangle, which are the same, both equal 6 square root of 2. If you look or are looking for a pattern, see how the hypotenuse is 12? 6 is half of 12. And then I just add on the square root of 2. So that's the pattern for these when you're given the hypotenuse and it's a whole number. Now, on the other hand, where they give me the side, all right, I know that these sides match because they have matching symbols on them that show that they're congruent. So that means this side's also 5. So this one's a little bit easier. I would go ahead and use my a squared plus b squared equals c squared, but I'm looking for c. That's what I don't know. So I have 5 squared plus 5 squared equals c squared, and that's 25 plus 25 equals c squared. And so I get that 50 equals c squared. And now I want to get rid of the exponent. Well, how do you cancel out a power? A root. So for both sides, I'm going to find the square root. Now, 50 is not a perfect square, so I'm going to break it down. And I'm going to do this kind of the long way just to show you. Like, what I would use is 2 and 25. But let's say you didn't use those numbers, and the first ones that came to your mind were, let's say, 5 and 10, okay? 5 is as simplified as it can get. Can't be reduced anymore because it's prime. 10 can be split into 5 times 2, and both of those are now as simple as they're going to get. So when I get to this point, I have a 5 times 5 times 2. And when two of them match, I can cross one out and kick one out. So x equals 5 square root of 2. This hypotenuse that I'm outlining in green right now is 5 square root of 2. So this one, where they gave me the sides and the sides were a whole number, all I did was take that same number and add square root of 2 behind it. So you might be asking, okay, why isn't this one over here 12 square root of 2? Okay. 12 square root of 2 is greater than 12. So when they give us the answer and it's like they give us the hypotenuse, should I say, and it's a whole number, that means the square root of 2 somewhere along the way was canceled out. And so that's where this might be extra, but if you reverse to this and you did a squared plus b squared equals c squared, 6 times the square root of 2 squared plus 6 times the square root of 2 squared. When I'm squaring these, I distribute it. So 6 squared times square root of 2 squared. 6 squared is 36. Square root squared cancels out, and it's just 2. 36 times 2 is 72. So I have 72 plus 72 equals 144. That's c squared. And if c squared equals 144, look, we're back up here at the top. C squared is 144. Then that means c by itself is 12. Hopefully this is a good refresher and reminder, and maybe for some of you it's what makes 45, 45, 90 triangles click for you. But after you've watched this video, go ahead and go to Schoology and complete